We may have to switch.
Do we have to switch? Switch for
Oh yeah, no, this room was open yesterday. I had class in here yesterday, yeah.
Wasn't Verizon down?
No, we didn't, we literally just had to, yeah, she literally just had to tell us about links or whatever.
I want to go to Shannon.
Oh, then I won't be able to stream.
You can still stream.
Well, yeah, but I won't be able to stream the board.
You don't have to start. I don't know what brought you.
I'm gonna open next door.
Oh, you know, it's frozen.
The schedules are decreasing. Oh, literally, like I had this 16 miles on the bus now. That's it. I'm getting screwed over.
Oh shit.
I hope that wasn't too loud.
Let me just see if I turn this manually on.
Oh, wait, another thing.
This is my bio classes that one here, and then 9 a.m. bio.
Do you like the first one or the second one better?
This professor.
No, for
This is a.
Oh, for sure.
first, definitely. Actually, the second one's pretty good though.
There's all of the, because I checked all the other bios.
You may have to take the lecture hall because you know if all the seats are available and stuff.
You should read esports. Hard stuff's wrong.
You know what? I'll do the horse.
Yeah.
I
It'd be
can
like
try.
that. Yeah.
If only I could put a lid
I
on
don't know if
this.
mine is right, but I'm gonna check mine. Oh wait. Professor, can I actually like code for this assignment real quick? Or do you want me to do it after class?
At the break or
Oh, okay.
or sorry. Before I, send sheet of cards, I'll get to you before we do lab.
After correction.
Good morning.
Morning.
Good morning.
How do you feel?
Yeah.
Yes.
Okay, I know this professor is really bad. Sorry. Pretty sure she's.
No, because I'm gonna. Are you taking it over data structures and algorithms?
CS 241.
Oh, am I taking that? I guess I am.
Should be.
Let me check my schedule. I didn't know what it was called. I know I'm taking Unix. CS 271, CS 241, Tuesdays and Thursdays.
Oh.
250.
Unix?
230.
Yeah, what time do you think Unix?
What time are you taking?
Monday.
I think it's like 12.
Oh yeah, I'm in
Oh,
that.
okay, never mind. I have to class right after.
Oh, yeah.
Do you
But
think
yeah,
it's math
I am
class?
taking it.
I mean, I think
Yeah.
it's gonna be a pretty good
Well,
class.
I
Like you can take it anytime you want. They say you just need
It's a freaking one.
data
It's
structures.
the only possible
But
state.
wait, what time you taking data
Yeah,
structures?
'cause I'm the
12 to 2.
Ah,
Yeah.
I'll be in it from 2 to 4.
Yeah.
Is it both master's classes?
What'd you say?
Are you master's professor?
Wait, they announced them?
No.
He's supposed to
I
be
don't know
teaching
who the professor
one
is.
of them at least.
Oh, one of them. Which one?
What happens?
Masero's teaching one of the data structures. Hold on, Jack. Did you say that the 2 to 4 class was better? Is that what you just said?
What?
Did you just say the 2 to 4 class is better?
I don't know. I think they're the same. I could be wrong.
Okay. Hmm.
I swore I heard.
He has a code.
Oh, that.
That's
Okay. So, well, it looks like we have to project it and play ball. So, I'll just take a brief look at what the assignment is, and I'll extend it until Tuesday because it's simple enough that you should be able to do it. Like we can talk about it if anybody has a question offside, but you should be able to do it. Fairly no problem. Like I'm sure it took some of you like 5 minutes, but some of you won't. So it's basically, make sure that you're able to look at something, be able to generalize, and then make a program use a different data structure. So, recalling that, you had to take a look at this, which was simple selection sort. So it had an array of integers, and then if you use this, you can see that it will sort the integers properly using the sorts class, and it's a static method, obviously because it's being called using the class name. So this is the sorts class. It's been converted from using a comparable. I always flip that. Comparable. So the comparable object was what was used to be in the parameter list. So now it's an integer array instead of a comparable array. So if you look at this compared to the former selection sort and insertion sort, and how this was changed to allow an integer array to be used, then you can easily change the linear search and binary search to use an integer array instead of comparable. But just real brief. But please do try yourself. Essentially, with your assignment, if it sorts an array of integers like this, then it works. It's done. Because a comparable object would not accept an array of integers because it's primitive. I guess there's a small chance, no, it wouldn't autobox. It wouldn't autobox that fast. Like if you do an integer and you place it into an integer object, it will autobox, but I don't think doing this into a comparable would autobox. Although, I guess I can try that real quick when we start with this. Autoboxing, anybody want to just quickly say what autoboxing is?
Autoboxing, like.
Yeah. So, as long, that's what you got to do with, that's what Java does. It's like, instead of doing the new operator, it just does the object. So what were you going to say?
I was going to say it turns a primitive type into its like respective wrapper class by just assignment.
Right. So if you just say integer x equals, and then you assign it to a variable that is an int, it'll autobox. It does it without the new. So it's like it's sort of like the string, not using the new, but it actually is workable. Whereas the string, as we know, makes aliases, so it's better able to use new with the string. So the class he had changed is this. Right. So if you look at this, you see up here it's got public T linear search. T is the return type, which means anything. So you got to change that to int. You have to change from T, which is a comparable type of object, to an integer array. And then anywhere down here that it uses the equals method, you have to change it to double equal signs because that's what you use to compare primitives. You use equals usually to compare objects. So if you do all that and you pass it an integer array, it should search it correctly. So as I was just saying though about the autoboxing, oh yeah, the original one accepts those contact list things, so it wouldn't even be set up to do it. Yeah, I have to rewrite it to accept integer objects and then see if it autoboxes up the flags. So not fast enough. So today we're gonna do probably the hardest thing in CS 121 and 122. Probably the one of the things that is also tricky when you do CS 241, we'll do linked lists. So the linked list built in Java generic generator is easy to use. So we're going to do that first, but then we're going to say we'll build our own one of these. So first we'll just see what the linked list is. So we just get some white space and see if there's a marker that works. So a linked list. So the kind of linked list we're going to look at is a singly linked list. So a doubly linked list would be like if you had chain links, they were connected one to the other, where one would be just as connected to the other as it was backwards as it was forward. So like this one is linked to that one, but this one is also, if you think about it topologically, it's also linked back to the other one. There's not like a hole in this one that this one just links through. They're both like linking each other. So this would be like a doubly linked list, which we're not going to do. We're going to do a single linked list. So a single linked list would be like if you had something with a hook on the end, and then in the back it has a hole so that one of the other ones can grab it. So then the next one has the place where the hole is. This one is linked onto it. So this one links to this one, but that one doesn't link to this one because that isn't the way that the transitivity goes. If there was a link backwards, then it would be like that. So a singly linked list will be where the first link has awareness of the next one, and then the second link has awareness of the third link. But backwards, they don't have awareness of each other because there's going to be something that will look like this in the program. Say, well, I think for ours it'll be string maybe, but it'll be some place to hold some data, and then it will say node next. So a linked list node holds some data. So say that this held 10 and this held 12. So it was like already partially sorted. And then the place where it says node next would be this part. So the first link in the chain, if there's only one link in the linked list, then node next points to null. So if there's just one node, then node next points at null because there's only one link. And then as soon as there's a second link like this, node next will point to the next link in the chain. So it'll be another place for the data. And then node next. So if there's two, then this one's null. So at this point, this is not null anymore, it points to this. But at this point, so the end of the linked list is always going to be pointing at null. So the first link will point to null just because it's only one link. If there is an empty list, meaning there are no links, then the whole list will be null. And that will be something that we'll look at to figure out how to erase the list if we want to, and look at whether how many links there are when we want to make extra methods. So we're going to make a list that basically adds links onto itself, and then hopefully interesting homework. Because it's interesting because you should be able to reason it out from the hints we give each other in class, but also you can look it up on the web too. So if you get stuck and you need to look up how to generate the isEmpty method for a linked list, look it up and then transfer the knowledge over to the data structure that we built. So a singly linked list, each link points to the one in front of it, but it doesn't point to the one backwards. A doubly linked list like this one would have in data node next and also node previous. So it would point forward and point backwards. Doubly linked lists are just much more intricate to design the first time, so we'll do a single linked list for the first round. And I always try to make it seem like it's going to be as easy as it's going to be. And hopefully it is easy for you, but the linked list is notoriously strange to understand. So I'll explain how it works and then take it on faith that node next points to the next node, and then we'll say how a node gets generated, how you make the next one, and then if you want to say how many links are on the list, we write a method to do it, but that's what we'll do in class. We'll do that one, we'll do if we've generated 5 links, how do we give it a method that says size, and then it gives us back the integer 5. How will it do that dynamically? So a linked list is a collection. So collections are abstract data types. So abstract data types, as we know, is so abstract data types are those types of data that we make up ourselves and design. So an int is not an abstract data type. An integer object is not an abstract data type. A string isn't. But if you write your own class, that really is, because you're making it yourself based upon an unknown design. So our linked list, even though it's going to follow the pattern that most linked lists follow, we can write it in ways that would be different from someone else's, although they'll be pretty close. So first we're going to write a, we're going to use the Java built-in linked list, where all you basically have to do is make an object and use the add method, and then you add things into the list. So the linked list that we're going to do, we can either leave it as accepting object types, or we can make it accept only strings, and then add 5 strings to it and print the list. And then after we show that that's easy to do in Java, just using the word add with the object name, then we'll build our own linked list abstract data type by itself, which will require one class that has also a class inside of it. So that would be something to a class for the class inside. And then there'll be one extra class for links of the linked list, and then the driver. So there's always at least questions. There's always 2 of these programs: the driver and the class that it's going to have. Okay, so it's okay, so an array, for example, is not an abstract data type, but an array list, if we made our own, is. So the linked list that we're going to do using the Java generic is much like the array list, except that it'll be knowledge that you'll gain in data structures and algorithms. That if you want to make a list that's going to constantly just be added to at the end, like say you have a list of 10 things and then you might need to add 11 and 12, then an array list is okay, but a linked list is better for situations where you may have to add to the front or to the back or to the middle. So they both have their own efficiencies. So an array list is like an array in that the underlying thing that lets an array list dynamically grow is that there's an array inside there, if you read the Java documentation. And every time it adds something to the array list, it has to destroy the array and make a new array of size x plus 1. So that's why array lists are better for just adding it there. Linked lists are going to actually use linked lists like we're going to do, but built-in Java version, that's all under the hood. But that the thing that we'll see is efficient at adding to the middle, beginning, or the end because of its link from one to the other aspect of linked lists. So we see here that this says that we're able to make a linked list object by saying linked lists, and this is part of Java. Capital L on both words. And then where it says string, you can leave it blank. I think a few slides forward, it just says object. And then you can pass it anything you want. So this way you'd only be able to make a linked list of strings. If you make it linked list object, you can make the first thing be a string, the second thing be an integer object, the third thing be a double object, the fourth thing be some random object that you made that the class is available to the program. So the object class gives you a lot of leeway. there's not a whole lot of advantage of making it string, but it does at least restrict you to only having string. So if you want to architect the software that way, then this will prevent anything but string being added to this. Okay, so this program, just take a look at it here, and then we'll look at it. So you see, this is the entire program. You just have to make a linked list object and then use the add method to add strings to it, and it's done. So when we write our own program, our driver is going to look just like this, but then there's going to be like 2 pages of Java code to actually implement this, because you can see here that there's nothing else except for making the linked list object magazine, saying magazine add with some strings, and then we use a print statement to print out magazine, and it's able to print it out because printline has overloaded for linked list objects because it's part of Java. So for us, we'll have to include a 2 string in order for the linked list that we make to be able to be printable. So let's look at this in the in the easy way it is for now, and then once we have an idea of what this looks like, we will go into the one that we're going to do long. Also notice that there's a magazine.size, magazine.index. Those are built into Java. The one that we're going to make first, all we're going to have is add. So the thing that you'll have a chance to play with it with yourself is like doing size, is empty, delete or erase if you want to erase the linked list. And anything else you can think of, like insert first, impact.
Why do we have this magazine that size, not the size -1? I guess for arrays we have array that.
Well, it's going to be an index out of bounds, obviously. Well, it's magazine size right here. Changing it is going to make it out of it. So -1, you would miss the last element. -1, yeah, you would miss the last element. The size gives you the number of elements in the linked list. Okay, so let's just run this, show it works, but we really don't see any, there's nothing to learn from this so much as the fact that we're going to make this. So we're going to have a class that we're going to call linked list ABT because we can't use linked list, it's already taken. We could use lowercase, but it's bad style to mimic a Java name just by changing the case. And also some IDEs won't even let you do it. Okay, so, I put a Z in the name, so now it will be known as linked list manipulation.
There's an S before the D also in linked in the class name link.
I think it's just, I'm sorry about it, but like reading this without reading glasses is like super.
Oh, of course, yeah.
So let me just look at it here. That's why I always go to the board.
Yeah.
Linked this demo. I have to do it.
Wait, it says let's Z. Fucking
I
X.
couldn't have such.
It says let's Z demo. Just get rid of the Z.
The part of me that is meticulous simply couldn't stand it.
Brittany, what's in this movie?
Okay. Alright, so this I think Alright, so when we run this, we're just gonna see each of these things printed out in descending order. So the reason that it's done using a loop is that you can print out just saying print and then say magazine, but it will give the special type of print that it knows how to print from the print string. So if you do it this way, you can have them print it any way you want using the method that is get. That's part of the linked list class. But if we just say print magazine, you'll see that it starts out with a square bracket. They're printed next to each other with commas and then a square bracket. So it's not as nice. So we'll show that by just commenting out. So we see that it prints out in descending order because of that loop. So if we do print magazine without the loop, it's just going to say bracket, time, comma, woodworking today, comma, etc. Because that is the way that the linked list generic class knows how to print out its own linked list. So we say Okay, so notice that it does let us print out magazines. So now we won't see it like that because we haven't customized it. So that's basically the reason that loop is there. Otherwise, you just have to say print magazine. And that's all we'll have to do when we print out ours because the loop is going to be inside the toString instead of inside the driver program. Okay. But it will be easy to do this way or the other way. You can do either way you want when we do the long version of this. So that's what we're going to do now. We're going to do this as our own custom file. Okay, so the interspersed program was the thing I said at the beginning that you can use object as the constructor and then pass it anything you want to. And when you give it a 1 or a 7.5 or a character name, it puts them in wrappers because linked lists only accept objects. So even though it looks like it's taking primitives, it's actually making wrapper objects out of those. So here's the stuff that we were mentioning in the first thing with the drawing. So class node, int info, and then node next. So node next was the hook that catches on to the one that's going to be ahead of it in the linked list. No backwards reaching. So a singly linked list goes from 0 to 1, 1 to 2, 2 to 3. So they each have knowledge of each other going forwards, but not backwards. So that is noticeable because it's node next. If you had node next and also node prev or something like that, then there'd be a way of looking backwards and ahead so that you can traverse the list in both directions. Okay, so, and this is a nice picture of it. Where the next field is actually going to be, it's actually going to be in code. It's going to say, next, and then it's either gonna point to null if it's the last object, or if it's the first object in the list and there's only one object, it will point to null. And the last object in the list always points to null. That's how the list, that's how you can determine that the list is finished, because the last one points at the Java keyword null. Okay, so take a look at this program. So this one looks just like the one that we just ran. It's, just like the one we just ran, meaning it just says print the object name, and it says add, and it makes an object. So it looks just like it, except that for ours to work, we're going to need to do the whole program that actually makes the list. And also one of the activities we'll do is, notice where it says new instance time, and then the other one just accepted a string. Well, we'll say, how do we change it so that we can just add in a string and not have to say new instance? Because it doesn't look as nice to have a constructor inside of a method call. But it works, but we can change it to make the other one work too. Okay, so just in brief, and then we'll look at it in Eclipse. This is the first half of the program that actually makes the linked list. That's the last part of the program that makes the linked list. And notice that it says link node next down here. So this part where it says private class, that is the inner class I was telling you about. So it is its own class, so you can either have it as an inner class and have the variables public, or you can make it as an outside class and just have the variables protected. But usually for a linked list, the methodology is to make an inner class, so it's private, so that only this class can access it, because private means nothing can access it at all. So if you wrote private class on a class definition that was just one class, it would be unusable. Nothing would be able to access it. But for an inner class, the linked list ADT class in which this class resides can access it, even though it says private, because it's sitting inside another class. So that makes a linked list, and then this is the thing that accepts the strings. So like on the first one where it says add, and then it accepts a string, the string goes here, and then string is set to this, and then this is where the toString happens, that it prints out the magazine title. However, there will also be a toString in the list. This just tells our constructor program how to print out the string that we give it. But the linked list has to tell the object how to print out the list. So how to print out the list is done in the linked list ADT. How to print the string itself is done here. So as we know, there's always a separate toString for every individual class that you are using in Java. Okay, so let's take it nice and slow. We'll probably have to go through it a few times. You yourself run it a few times and change some code, just because it is, admittedly, it'll be a nice thing for you to understand what you get. So notice that this one is just like ours, except that it says ADT because this is our own class. And where it says new instance, that was that last small little program where the toString for printing the string was. So new instance is actually where you pass in the string to. So you pass the string, for example, time, for Time Magazine, the magazine title. When you pass that into new instance, it's going to be passed to this very small program. So we pass time into here, it receives time there, time is set to the global variable title, and then the toString prints out time. So when the linked list prints out the list, the first link in the list is ready to print, it has to call this toString, print out time. Next link is ready to print, and then it has to call this to print out the string title. So that's the way it will work. this also we could have made as an inner class, but that would be too much. Like the inner class of the node is better because it encapsulates it better and it makes it so that the linked list ADT doesn't have to worry about managing things so much in and out of the node. The node is usually part of the linked list class itself. Okay, so let's grab this long program now. And we'll start. First, we'll just run it, and then we'll start out by trying to get rid of that new instance part. So it'll be a way for us to see how it works. So, okay, so here's our program. So we'll just run it and we'll see that it's going to print out in a descending list just like the generic did before we had removed the ability for it to print descending down the page. So all this one says is to print magazine wrap. That's the object of this PDF. So it says print magazine wrap. So there'll be a print string in linked list ADT that first does that. So printing the list is done by linked list ADT. Printing the string part of the list is done by instance. So let's do. So we see we've got our list. So now, first thing we'll do, and we'll do it the normal way that you can do things for yourself maybe. Say that we don't want to do this. We just want to pass it time is working today, but with no new instance. We want it to look like the other. So let's just take away new instance and see what the error message says that we get when we do that. And then that's usually a handy guidepost to say what you got to do to make it work. So this. So I've removed that, and now I have an error. So it says the method add instance in the type linked list ADT is not applicable for the argument strings. So that means that the method called add that's in the linked list class doesn't accept strings. So let's go to the linked list ADT class, find add, and then somebody can suggest what we're going to do to change add so that we don't have to have the new instance here. But if we don't have to have it there, then we probably have to have it somewhere else. Yeah.
I have a question. So basically, new instance is a very bad option to use strings for linked lists, right?
But no, it's just that you usually don't want to have external constructors inside of a program that a user is going to be
Because
using.
it takes more time, right?
No, it's because you don't want to give the user any insight into how the program works. You tell them you can pass it strings, and that's fine. But if you tell them there's something called new instance, they'd have knowledge of the programming that breaks encapsulation. That's right.
Oh, so we have the values to encapsulate are private, right? So we don't want the user to access the data we assigned, right?
Right. Because by giving them the ability to use a constructor that's an internal part of the program, they can do something. So usually you just want to have a method that accepts a parameter, but you don't want to have the user to put in the word new. Like if it were non-computational users, they would have no idea what new instance was. Like they wouldn't know what a constructor is.
So we will increase readability of our code, right now.
Yeah.
Okay.
Yeah, I did it this way just so that when we change it, you'll be able to look at add and say, well, does this now? Where do we change it? So now let's go look at add. So what we wanted to do was have time passed to the add method. So this says add is not applicable to the argument string. So we go to linked list ADT, and let's just skip over the first part, which we'll look at in a second. Let's just look at add first. So add says instance node name. So when we tried to pass in time is a string. So before we do anything else, like just one step at a time, what can we do to add? And forget about the linked list part. You know how to do this already. If we want to pass the string time to add, what do we have to change the parameter list to say?
String node name.
String, yeah. String something. So we can say string node name. So let's even use that, and then we'll have to do something else for when we do the forwards. Let's change this to string. So when we change this to string, stuff down in the add method is going to break because now it's going to be looking for the instance object. But now if we go back to the driver program where we're passing time to the add method, that's not going to be broken because we changed the constructor to set what we need. So now we see that this is fine because the add constructor now wants a string. And now all these are broken because it's going to say the method add is not set up for the argument of type new instance because we changed the constructor. So we got the first thing. So we can pass a string to the add method, but we still need to have new instance objects because they're part of the built-in linked list. So now we go back to the place where we just were. So here we are. So we're here right now. So instead of this saying new linked node name, okay, so here's the thing to maybe somebody can no mention. Maybe somebody else can just puzzle it out. But it's not going to be too involved. So this normally says instance node name. So right now it says string node name. So this is where we do the time length. So normally it said instance node name. And now it doesn't say that anymore, so it's being passed to string, but we still need node name. And we'll change this to nope, we can't do that. We can call this node element. So we used node name to pass in the string. So now link node still needs, so node name was formerly what kind of object? It used to be a what? Instance. It used to be an instance object. So node name still needs to be an instance object. So we've gotten the string to the add method. So time is here. How do we wrap time up in an instance object and then pass it down here?
So we use autoboxing.
Pardon me?
We use autoboxing to convert to autoboxing.
Well, what did we do when what was the constructor that we had in the add method in the first?
New instance, right? We had new instance constructor with new instance
Yeah.
and time.
Yeah, so,
And we still have this time, not link, right? So we want to convert from instance to string.
no, we want to convert from string to, we want to make it string to instance. So
Okay.
if we had add new instance, then we have to put, this can't just be a string because it
Okay.
needs,
Okay.
it
So-
needs,
So can I count? So can we just have instance not named equals no string not named and then pass it to the link node.
yeah, we can do that, and I'll do that as one of them, but also we can just put the constructor, we can just say new instance.
New instance?
Yeah. 'Cause-
And if we say this new instance, would we need to say new instance in the program?
No.
So it would be fine, right?
It'll be fine that way. So we can do it beforehand and just pass in the name of the object we make, or we can just do the constructor inside link node, because it's following a calculation that way. The user can't see inside this. So we'll do it both ways. I'm however just gonna make this a different name because I'm not sure if node name is used throughout the program a little bit more, so recall that originally it was this. So here's what we're doing. So it was originally instance node. So instead of making the instance here. We made this accept a string, but now we have to get the string here. So we need to say new instance here. So we're gonna call this like string x. And then we'll make the new instance object and then pass the name of the object to link node. So it'll be all wrapped up within inside the add method, encapsulated from the user view where it will work. So if we just say string x. So if we go back to the driver program, you see that time is still good because we're passing just a string. So that's all set up. So now I can take the new instances off all the rest. However, if I run the program, it won't work because the add method still isn't finished. Okay, so all the errors are gone, so the driver's ready to go. But add won't work. So if we run this right now, we'll probably get a run. There's something here. So it says, so node name can't be resolved to a variable. So node name, it needs its node name to start building the links. It needs an instance in there. It's not there, so now we have to go attend to that.
Can you explain once more? What's wrong?
So-
Do we need to initialize the list first before we add something there?
Well, I'm gonna retype what was there and it's gonna be a little more clear. So our new version is like this. So formally, by saying add new instance, it made a node name object. But since we removed this part, node names aren't being made yet. So we need to make the node name, which is an instance object. So let's look at the instance class again real quick. We're passing strings in. However, we're passing them into the linked list ADT class kind of like, by the way. They're going to pass it on to instance, and then that's how the string is going to be printed. So the string time is part of is being sent by the add method to linked list ADT. So we go there, and you see that the add method receives our strings, and now link node to start building the list. It's not fixed up yet because we need to say node. We need to say instance node name equals new instance, and then pass it to string x. So we'll do it the long way, or we can just put the constructor inside of link node. Either one will work. So we need to pass the string x to the instance object, which isn't there yet. So we need to say instance node name equals new instance x.
Or you type double C in the instance.
Oh, thank you. Okay, so we can also just take new instance x and put it right there. So we'll run it both ways. So now we've made our node name and passed it the string, whatever the string is being passed through. So this is what was being done in the original driver program. Each time the string was being passed in, it was being passed directly into an instance object. So instance is that outside class. So we look at that real quick in the relational program. So it receives a string and then it'll be able to print the string when the linked list ADT program wants it to print the string. So now we go back here and we see that it says we have our node name, link node, now receive node name. This will work. So now the whole program is going to run. So let's run it that way, and then also let's show that you can put the constructor inside of the new link node constructor that's popping out.
How come you had to change the parameter name from node name to x? And, why couldn't you just have it be
Because
straight? node name and then cast it as an instance? Or like why do we need to create a new instance object?
Because this originally received an instance object that was created back in the driver program. So the driver passed it a string, and then it was wrapped up in an instance object. So passing it a string, you know, what you're suggesting by casting it, maybe that would work, but there's no reason to cast it if you don't have to. So we have to make an instance object. So like the way it was done before, it said like magazine rack add quotes new instance and then time was in there. So then this was sent right there. So like node name was already done. It was done by the driver program. But here we still have to make an instance object. So if the string is here, we can't just say link node equals new link node string. That's not good enough.
But can we say link node nodes equals new instance x? Can we?
Yes. So that's what we'll do now. We'll just show that we can
I have a
put
question.
the chain, the constructor inside of it. So either way it's fine.
If we pass like 10 million objects into the link node, will it affect runtime if we have first instance object and then we assign instance object, or it will be the same as we just cast them?
Well, I gotta make sure that it's not gonna have a problem that we're declaring a variable here. We might declare this variable name up where the class variables go. That's always a safer way to go. But I think it'll be alright. Let's just try it. But as far as what you just said, you'd have to measure it. Always measure it. Okay, so we see, here's our program. Oh, so fun stuff. It didn't work yet. Huh. So I had this back there. Okay, so we see it work because each add method is doing the following. So each add method is saying, send this string to the add method. The add method says string x. We're working today is assigned to x. We make an instance object that has x passed to it. So now an instance object that has a string, we're working today and it's been created. And then link node, which makes the links in the linked list, accepts that instance object and makes the first link. So that's the process. You pass the string to instance, instance is passed to link node. Link node is the actual link in the linked list. Okay, and then the other way to do it is by not declaring everything altogether, but just by taking this part and okay, so instead of doing that entire line up there, we can take new instance x and put it where node name is, and it will be the same thing. So that way is, good shorthand, and it's also okay because the user doesn't have access to this part. So this will also work, which was just like it was done in the driver program where it said add, but then you never want to have your driver program have chain constructors usually. So we go back and just test it, and we see that it works. Okay, so that at least gave you the, yeah.
Does the instance class take in a string? Like, does it accept a string?
The instance class is the one that has the ability to print the string at the end. So the instance is whatever the linked list is going to hold, the instance class manages the type of thing lists.
Oh, okay.
The linked list ADT class makes the links, but the links are all generic. You can hold any. Instance says we want strings. So
so we're doing this like if we specifically want all the
yes,
data. Oh,
we could make instance to accept objects, but then we would have to constantly cast things, so it wouldn't be as easy to do. Okay, so we've got So that was without looking at the rest of the program, we saw at least a little bit of how the admin. And now let's start from the top down. So we have the name of our class, link list ADT, and here's the default constructor. So it says list equals null. So that means that when this class loads, it makes an empty list. So just here's the thing I want you to keep in mind for when we have to make some of the guesses that the other methods will do. If this says list equals null, that means that it's making an empty list. And also, if you wanted to make the list empty, saying list equals null will empty the list. So hint on that one if you ever want to empty the list yourself. Just saying list equals null deletes everything in the list. So now back to our add method. So we saw that it accepts a string, and now let's look down where it's actually going to start building the links from the first one, and if it's not the first one, then do something else. So it's either going to be the first link, or it's not going to be the first link. And we'll do two different things depending on those situations. And the very first thing was private link node list. That's the actual name of the linked list. So private link node list makes a variable of type link node. Link node is going to be the thing at the end that had like info and node next. So link node is the actual link. So list equals null makes link node list, makes that list object an empty list. No links in the end. So now with our add method, we're going to make one link at a time. So let's change our driver class so that it's only going to be passing in one link, so that we can talk about the program in a relative fashion. So when we pass in just one magazine title, we're only going to be making one link. So here's what's going to happen. First I'll put it up, and then you can take a look at it first before I say or suggest what's going to happen. And if you look at it, you can have a guess as how the first link is going to be built. Or you can suggest if you like. Just make this clearer. So everything for making the links is right there. Aside from how the link node class works, making the first link and the second link is all right there. So, which part do you think is used for making the first link? The if part or the else part?
If part.
The if part, yeah. So it says if list is null. So list is null when the program first starts out. So if list is null, there are no links. So you make the first link. So if list is null, then list equals node, meaning the thing that we pass an instance object containing a string, that's node. So if list doesn't have anything in it, make the first thing that you just passed it, which is Time Magazine, and make that the first line. List equals node. So we assign node to list. Node is the first link. Node is going to be each link, but node is the first link. Done this way, if the list is empty. If the list is not empty, then we don't say list equals node, because if we did that, then we would add one link, and then if we said list equals node for the second one, it would erase the first link and put the second link in the place where the first link was. So if we had this in both places, it would simply take time, put it in, and then woodworking today would be put in, but time would be erased, and then communications to the ACM would be put in, but then woodworking today would be erased because it assigns it to the entire list. If it's not empty, then this something else part is done. So else current equals list. So the kind of thing happening here, but not totally exactly, is where it says current equals list. You know, say you have x equals 8, y 7, 10, 0, and then you wanted to swap the values of x and 8, you can say 10 equals x equals y, and then y equals 10. So a swap isn't going on here, but where it says current equals list, current is able to hold on to whatever the list contains thus far, so that you don't overwrite the whole list right in the list, much like that. So current is like a temporary variable to hold on whatever the list has. So if the list is null, then make whatever you just passed in the first link. And if the list is not null, then hold the list inside of the variable current. And then while current.next does not equal null, meaning if there are still links to add, current equals current.next. So current.next is the next link in the list. So here's the part where if you're a linked list born pro and it's clear, then don't listen to what I'm going to say right now, just like hold your ears. But if right now you don't get it yet, don't worry about it, because this is the part that's just like a little weird, because we haven't still seen how link node works, but even when we see that, it'll take a few times going through it to get what's going on. But as far as like doing the understanding part, this is where the whole list is built. So if you trust me on that part, this makes the first link, and then this part sets the list equal to a temporary variable, and then the code current.next takes each next link and appends it on. So if we did 5 of them, the first one would be done here, and then the second one would be done here, so it would be current.next. The third one would be done here, current.next, and then once we get to the end, if there's 5 and the 6th one is null, then it would say it's done, and then the 5th one will have its next field pointing at null. Just like if we only have 1, like I took out all of the list and I just made it Time Magazine, so we run that, and it says time. What happened? Who wants to describe what happens back here in Java code? What's the entire linked list if only one string title is being sent to it? Where's the action happening? In the end, yeah. So if list is null, which it is, then list equals null. So list is time, it's done. It doesn't even look here because it's finished. So let's take a look at the link node class so that we can get an idea of how the nodes are connected up one to the other. So notice that we have a link node. So like time is a node that's going to be part of the chain. And then link node current is that temporary variable that we needed. So it's got to be of type link node because they're basically the same thing. But current is just a temporary place to hold whatever the list has so that you don't overwrite the current contents of the list. So let's go to down here. So the toString is first, so let's not look at that yet because that's not the important part. So here's the part where, if you remember from the lecture, and I'll erase that marker stuff. If you remember from the lecture, this slide right here is the Java code we're going to look at next. Link node is this. Okay, so we have a node, it's got info, it has node names, singly forward linked list. I suppose you could write a backwards linked list, but I don't know of any actual usage of them, but they would still be singly linked lists. So now we look at linked node. So it's got a next field, and it's got okay, and then it's got our instance field. So each of the nodes in the linked list is managed by link node in the following way. If you think of each node as like a cardboard box, like the top cut off so you can just drop stuff in, it's on a conveyor belt. Link node is the empty cardboard box. And then instance is the thing that has a string in it. So link node comes along, you drop instance that has a string in it, and then if there's only one link, then link node points toward null. But then if there is time is first and then woodworking today is second, link node, the first one, has the instance that has time in it, and then next will point to the next node in the list that points at the one that contains woodworking today. So for the first link, next is not null, but for the last link, next will be null. If it's a two-link list, then the second link points toward null. If it's a three-link list, the third link points toward null. Whatever points toward null, you essentially be dropping everything after in a list. Meaning if you make a 7-member linked list and you arbitrarily set the third member is next to null, the four members of the list will just be sent into the blink. So by assigning next to null, you're either designating the end of the list, or you can also make a method to arbitrarily remove part of the list. Yeah, that would be a weird method for a linked list, but say if you just said a method that said delete last 3, you would find the end of the list, go 3 back, and then set next to null on the one that was third from the back. So this null aspect will be a handy way to determine whether or not the list has any members when you want to do a isEmpty method. And also, if you want to erase the list, you simply have to say list equals null, just like we did when we made the empty list. List equals null will erase everything and just make an empty list again. So let's do a break. Let's do a break. And then we'll look at the two-string. But if anybody wants to play with a couple of methods So let's do our first fun method. Hopefully, so print it out and then let's make a method that says
Show you the part of the I for me I just did that with
okay, so let's do this. So I've written in magazine rack dot is empty. So an is empty is usually done so that it's answering exactly what it is. So is it empty? Yes or no. So is empty true if it's empty, false if it's not. So if we have any members of the list, it should be false, and if we do it before we add any members to the list, then it should be true. So why don't we add in that method name, and then this is the easiest one to do. So I will hopefully ask. You have the bad luck of having your test on the top, so we will ask Jordan if he can suggest how to make that. But it's going to be easy because you already know how to figure out if it's empty. How do we? An empty list is one property. When we first made the list in this class, what is an empty list? What property does it have? Like what can we look for? If the list is empty, what about it do we have? When we first make the list, it's empty. So when we first make the list, what word do you see near it? So no. So if it's null, that means it's empty. So we have to say, is the list null? So that's what we'll be asking how to do. So we're going to be making the is empty method say, is list equal to null? But we have to just figure the easy Java code for doing that. So we need to say, is this inside of our is empty method, then also have an option for if it isn't. And it will return true or false, which is which data type? Yeah, you got it. So we go down and we can put our is empty method anywhere we like. So I'll put it before the add just so you can prove to yourself that even if it's before add, it will still work. So public. And since we're going to have a return a boolean, what will the method definition be? Jack?
Like, I would think of his else statement.
No, just like we're going to call it is empty, so what it'll be public something.
Oh, Boolean.
So we're going to have it return a boolean, so we need to have that there. We're going to call it is empty. And since we're not passing it any data, then the constructor is empty, so you can either do empty parentheses or you can say void. Both of those are the same, but I think the more accepted thing these days is just to have empty parentheses. So we have our method, and it's giving an error because it wants us to return a boolean. So how do we say inside of this if the list is null, then return true, and if the list is not null, return false? Who wants to say? I know that you guys don't have to go. If you just don't feel like it, because it's only 11:30, but like, so you know, is the list null? If list is null, return true. How do we write that? Yeah. Yes.
So then if list equals null.
Okay. So if list double equals null,
So then return.
So, and the reason that it's saying error still is that list may not equal null, so it hasn't satisfied that it's going to get a return. Sometimes when you're doing a boolean that is like this, it's more common to put the return right after just to save some programming space. And then we can also say else. So if the list does not equal null, so we can say else if, or we can just say else. We'll just say else.
so you can see how it works.
because there's only one option, either it's null or it isn't. So if it's not null, then we return false.
And you can see that people can say the person in test practice really clever.
No, you still don't see.
points.
Will it work?
Will
Will it work, Jack?
I think so, yeah.
I think so too. So we made it as empty. It says, is the list null? And if it is, return true, and else return false. So this checks list. Is list have anything in it? And if not, then say that it's got stuff in it by saying false. So very easy way to make our first method. And this is one of the ones that you can do for, which will be to hand in by next Tuesday. So if you can remember how to do it or just do it your own way, this is one of the valid ones. It's probably the easiest one, but we'll do a couple more as time allows. So let's go and try it. So now we have down here our is empty at the end. Let's put it at the beginning. So right now we have is empty before the list has anything in it, and then after the list has something. We just have to have it at least before the magazine rack object is created. So this one should say true, last one should say false. And then we got, so like, that's like very cool stuff. You can see like how to generate methods for a truly intricate to understand data type. You just look what's in there. Even if you didn't know how a linked list worked at all, and somebody said, tell me if the list is empty, you find the place that says something like list, you see some null in there, probe for null. So it's a matter of reading the program, which later on, you have to read 50, 60 pages of stuff you have to maintain the code for. Nobody's going to give you the whole lecture about it, so just read through it and then try things. But obviously, if it's going to be someplace that the code is shared, you'll have to take a local copy of whatever the shared GitHub. So we have our is empty. So now the next two can be either erase the whole list, that would be one option, or say how many items are in the list. Who wants to do which one? Maxim, which one do you want to do? Do you want to say how many items are in the list or erase the whole list?
We can erase the whole list, I guess.
You picked a good one, because erasing the whole list is, actually that one is the easiest of them all, because for doing our probe of is it empty, we have to check whether or not this was true. To erase the whole list, our method called erase list will have one line, which is, what's the line going to be?
So list, assign or list.
So
Do we have a function for our linked list, like delete all or?
well, you could do it link by link, but that would be crazy. Like, you just delete the list.
We just delete the list, right?
So deleting the list will be one character less than what I have highlighted. We'll just say public void delete list, and then
List
equals.
equals the list. No.
Yes, null. So list is null in the beginning, it's empty, so to make it empty again, you just say list equals null. So if we just say public, and it's not going to return anything because we just want to have it do something. So if you ever have a method that just does something, then you know that it's void return type. So we say erase list. And then we just say list equals. So one equal sign because we're doing the assignment again. So it's basically the same as the default constructor, but it's a method. So if we call the erase list in between every method call of add, at the end the list should still be empty. So we'll try that after we try it just once, but you'll be able to see that it will erase the list at each stage of the game, or we do it all at once. So list equals null, it makes the list have no links anymore, void, doesn't accept the parameter. So let's try putting a method called to erase list right here. And then we'll try printing. So say so we'll print the list once it has one number in it, just how that is. Actually, let's get all the rest of it now. So we can start. So we'll have, it'll be empty at the beginning, because we saw that it was empty. So it will say is empty true, and then it will add everything to the list, it'll print the list, and then it will say is empty false. And then it will erase the list, and then we'll try to print it again and ask if it's empty, it'll be empty again. Because we'll have made it, printed it, erased it, and then tried to print it again.
The erase and the empty and erase list methods, are they built into Java?
Well, they're built into Java, but not ours, because we wrote that. So ours only does what we let it go ahead. So we had to write it down. So any of the built-in methods for Java, which are kind of sketched here, but not all of them. The one for the generic will have a bunch of these. So remove size of, so we can do size of next if we have time. Insert means insert into a specific position. That's probably the hardest. Remove just means remove one from the end. If you want to remove from a specific position, then it's a little more involved. But size up will be interesting to do, but I will ask Diego to help us do size up next.
Oh yeah.
No, I could tell that he was, I saw that he already had it there. He was telling his neighbor, he was like, I got this size up ready, so I don't know why I'm here. That's fine. So we have a race list, and it doesn't like that it is being called yet. Not applicable. Type void. What did he say that? Oh yeah, sorry. So why can't I print it? Erase list has property of
Let's see.
doesn't return anything for us to print. I mistakenly thought that I could just put it into one of the print statements, but erase list is just a service method. So it just does things. It won't give us back an answer unless we built in a print statement. So this will simply erase the list when we say this. So now, if we print the list again afterward, the list will be empty, and then the is empty will say true. So we'll see is empty, false, it'll fill the list, it'll print the list, is empty, is empty true, fill the list, is empty, false, and then erase the list, and then we'll try to print it, there won't be anything there, and then it'll say is empty, true again, because we erased the list. So we have, at first, when the object was first made, the list is empty, filled the list and printed it, is empty, it's not, because it has stuff in it. Here we called erase list, and then when we printed the list, that's this space right here, actually a space for the print line. It's just empty because nothing was there, and then is empty, true. So list equals null simply sets list to a null object and gives us our empty list. Okay, so Diego, what do we got? So we need to say size of, so this one is going to be size of 5. How are we going to have size of 5 printed out when we add 5 strings to our linked list? When we first make the list, how many links are there?
It was empty.
Well, that's a good answer, because I was actually thinking of one step ahead, but that's the correct answer. So when it's first made, the list is empty. So We can even make the variable there. So if the list was empty, you would say it had how many links?
Wait, I don't know how many what?
If the list didn't have any links, it has how many links? Zero. So if we wanted to say, keep track of links, meaning how many, we can make what type of variable to hold 0. And what primitive variable is usually held holding integers. Which primitive variable usually holds int integers? Int.
That's
Usually the answer is int. It's just if you think about it yourself, you'll think about it.
Integer holds integer.
So that was my little Polish short. So let's say int count equals 0. Okay, so the count is 0. So if we wanted to, so right now it doesn't really do anything except for when the list is first made, it doesn't have any links. But if we wanted to say print out the variable count from the method size of, what would that method be? So I will write just the basic part of it, and then you can let me know the return type and if it takes forever. So we need a return type right there, and we need size of there. Okay, so what's the return type going to be?
It's gonna be
It's going to be returning it. So return to. Okay, so since int is available to the whole class, does this actually need to accept a parameter? No, it doesn't need to. So size up just needs to return
count.
return equal. So let's see if this gives us a nice big 0 back when we say size up.
I'm gonna get
So put this up with the, I'm going to put count here, but I'm going to declare it with the integer. So divide it. It's okay. So we got return count. So let's go back and let's place it somewhere where it's actually going to make some sense. Let's do size up when we know that the size actually is 0. So we'll say print out size up when we know that the list is empty. Size up. Okay, so if we do is empty and we do size up, if it's empty, size up should be 0. So we'll have to attend to that. Because now we have a null method, so we have a way to get rid of everything. So if count has numbers to it, we're going to have to make count go back to 0. So now there's a few things to think about. So let's just see if size up says 0, and we'll know that we're at least on the right. So size of 0, perfect. So when we add the first link in, how many links are in the list?
0. We have the first one.
1.
Oh.
So Diego is still on. So when we had the first link in, we were so the first link is done at the if statement. So there's no curly brace right now, so we have to add in curly braces. So that's why I usually add them, but I left it out for now so that we demonstrated it. If we said count plus, if we did this here, I'm not exactly sure how well it would work, so we want to have our curly braces. Okay, so now when the first link is made, count goes from 0 to 1. So now if we do size up after the first thing is added, it should say 1. But then if we do size up at the end, it will still say 1 because we haven't given it the opportunity to increment for the extra ones. So this is just for adding in the first thing. So if we take size up and we put it after time, it should say 1. But then if we put it after woodworking today, it will also say 1 because the woodworking today part is added during the else part of the add. So we see it says 0 at the beginning because it's empty, and it's 1 when we add in time. But then it does an increment because we have to add in an incrementer to add. And then we'll say 5. So we go back to our interesting keys. Now, since we put count plus plus here, we just put count plus plus at the end of where the subsequent nodes are added. So now we'll say 5 at the end. So we'll do, but do notice the following. We're going to do, we're going to see that it's going to say 5, but it's not going to say 0 at the end when we've erased the list, because we're going to have to add something to our erase method to get count back to 0.
Excuse me, is this are the updated Java files going to be posted on Blackboard?
No, because this part you got to do. You got to pick one, pick a method, either any of them that we're doing right now, and you can just hand it in. So if you can remember this or you can type it, then it's good enough. But think about it, because it's a good exercise.
Wait, where are we submitting the method?
I haven't put that one up yet.
Okay, so you're gonna put it up, right?
So now this one will increment 2 through 5 after the other 4. So the first one, the if statement does 0 to 1, and then 2 to 4, 2 to 3 to 4 to 5 is within the else statement. But if we look at our program, we have the erase list. So when we do erase list, the list is going to go to null, but is count going to go to 0? Just because we said list is null, does count get bothered at all? So what do we need to do to get size of match up to the fact that the list is empty? Where do we need to put something about the count there? So what do we need to do to get count to match yes, it's empty? Where are we erasing the list?
Do you add like count equals 0 in the erase list method?
Right, so in the erase list method, do what to count though? Just
Reset it.
to, you're there, just reset it to 0, 0. So list is null, count is 0. Erase the list, get rid of the list, and then make sure count is brought back to 0. It'd be nice if there was more of a one-to-one connection between them, which I'm sure we could do, but it's also like a little bit overkill. And the fact that the list is null should indicate to count that it should be 0. However, that could maybe be an exercise for you to think about. But in this case, we're just saying count is 0. The only danger with that is that if somehow the list actually did have links in it because something properly wasn't done, then the count would say 0, but the list wouldn't. So, but here we do know this. So it's the same. So now we go back to our driver, and we'll have a file. So we got, get rid of this, get rid of this. Okay, so in the beginning it does, is it empty? Yes, size of 0. It adds all this stuff to the list, and then I'll say, is it empty? No. And then we'll do size of, and we'll get 5. So we'll use here. Okay, so we have the following. So in the beginning we have, is it empty? Yes, size up will be 0. It'll add everything to the list, and then it will say, is it empty? No, size up should be 5. And then erase list will say list equals null. And since it's setting the list to null, it also sets count back to 0. So then we print it, it's empty, there's nothing there, there's white space. Is empty says true, and then size up will say 0 again, because the erase list set the list to null and also the variable count back as we have here. So whenever you're making up methods that have to do with each other, we did the erase list, and then once we do the count part, and we increment the count's got to be decremented. So if you ever do if you do one of the ones that does a insert or delete, meaning insert a single element or delete a single element, you'll have to decrement count by one. Count minus minus inside of that. So what I'll essentially be putting on Blackboard for the assignment is just this slide. You can pick another one if you can think of one, but remove. Well, I'll define it better when I put the assignment up, but you can pick any method that isn't already in the PowerPoint. So if it's not the add method, you can include it. So we did as empty, we did size up, we did erase list. You can use those. You just need to do one. And you can also do insert at the beginning, or insert first, or any other type of method you can. But you need to do something else that is not the add method. And there's stuff about the Java documentation for those lists, but the best thing to do is just take the program and try stuff. Like we saw the place where, just in one last hint about it, if you wanted to do something where you were inserting links in a special place, remember that the first part, the first list node is added here, but then the second one's are added here. So it's going to be something like with the current content. So that part, you just keep copying and then delete something. You try to print, for example, try to print current in the middle, see what it looks like. So you get an idea of what's happening as it goes through adding links to the list. And then you'll have a better idea of how to go at a certain node. But the thing about a linked list, I guess one last thing is, there's no array value for each link. Like array 0, 1, 2. You have to traverse the list to get to a specific link. So if you need to get to the third element of the list, you have to begin at the first one and traverse to the third one. You can't just say link 2. There's no indexing like that for the list. So you have all this stuff up for on the lecture PowerPoint. So just have fun doing that. If you want to stop by for some help, more than happy to sit with you to do that. The thing that is due for Friday, I'll extend until Tuesday.